Okay, let's follow a bug around. It starts in location, x equals 12. On the x-axis at 1 p.m., walks along the x-axis with the velocity shown in this graph down below. Our goal is to figure out how far does the bug travel between 1 p.m. and 3 p.m. And where is the bug at 3 p.m.? Okay, so maybe you weren't expecting to do a problem quite like this, but we're given a velocity function, and we want to know how far did the bug travel. So basically what we're going to do is break this velocity function into nice manageable shapes, right? So between 1 and 2, we can say it was going at constant velocity in the positive direction, going at 10 feet per hour. All right, so to make this calculation, we're going to say that's a rectangle. We want to calculate the area of that rectangle. So it's going to have a height of 10 and 1 for its width. All right, so base times height or length times width, that means it's traveled 10, and in our case, that's going to be feet in the positive direction. Okay, so it's moved 10 in the positive direction. Next, let's look at this triangle. It appears to me that that triangle is only half a unit wide, like a half an hour. All right, so its velocity is decreasing along the way in that triangle. But a triangle, we can make that calculation of the area as 1/2 base of 1/2, right? It's only half an hour, right, till about 2:30, and multiplied by the height. All right, so that's 10/4 or 2.5 in the positive direction again. So that's going to be 2.5 there. All right, let's do something very similar for this bottom triangle. Looking right here, we can go ahead and say, well, it was 1/2 base of 1/2, and then the height, this time it's -10 if you want to say it that way, or I'm going to say +10 again. So again, we get 10/4, which is 2.5 for the area of that triangle, but it's like it's moving in the negative direction. All right, so the first question let's try to answer, now that we've done all of our calculations, is how far did the bug travel in between 1 and 3 p.m.? All right, so it actually traveled in the positive direction and then in the negative direction. So it goes 10 in the positive direction, it goes 2.5 in the positive direction, but then it turns around and goes 2.5 in the negative direction. So the how far question is actually, you want to add all of these together, which seems a little bit confusing at first, but it's going to be 10 plus 2.5 plus 2.5. All right, and thinking through this, just because you end up back here, all right, 10 units from where you started, you did all that walking, right? If you have a fitness monitor or something like that, if you go 10 this direction, and then you go 2.5 further, and you turn around and go 2.5 in the negative direction, it counts all of those as steps, right? That you would add them all together. You don't subtract off if you turn around and instead of walking to the east, you walk to the west. All right, so that's why it's going to be positive 15 feet for our total how far. But the other question kind of is, where is the bug at 3 p.m.? All right, so where is it? Well, what you want to do is you want to have whatever your starting amount is. And then to that, you want to add the change. So the change in location in our case. So our starting place was 12. But then we can represent that change with the integral from 1 to 3. And our function name was Vx, so we'll put a dx after this. All right, that definite integral, jumping down here, is basically like, that takes into account both positives and negatives. All right, so that definite integral would be the 10 plus 2.5 minus 2.5. All right, because the areas above are positive and the area below is negative. All right, this takes into account the fact that he turned around and he's closer to home than where he kind of ended up. Well, in this case, positive 2.5 and negative 2.5 can go away, and he's going to work out to be 12 plus 10 makes 22. All All right, and I guess it would be 22 feet from 0. If we're thinking about walking along the x-axis, it would be an x value of 22. All right, so I hope this helps out. A little bit tricky that we have two different questions and you don't quite answer them the same way, but hopefully it makes sense how we explained it out, why even though it was below the x-axis, it gets added for how far as our total distance, but you subtract it away for where its location is actually going to be. Good luck.